Hi guys, we will just start in a minute. So I hope everything is clear. Just let me know if you are able to see my screen and the sound quality is good. And we'll just start in 1 minute. Okay. Okay. I got ping. Joy Lakshmi. Hello. Hey. Hi. So I hope everything is good. Everybody has logged in. So just give a hi in the chat section so that we'll get started in a minute. So let the folks join actually. So whoever has joined. So today we are going to discuss about the dynamic programming. Smita madam says hi. So okay. So I hope everybody are able to. I have pinged the details in the WhatsApp group also. So if you are not getting the link or something like that, just get it from there. And we'll be today we'll be starting with the we have already know about the dynamic programming. So we'll be continuing that. We have already discussed about the greedy approach and all. So today we are going to discuss about the dynamic programming. So there are different algorithms are there for dynamic programming, like LCS, longest common subsequence, MCM, matrix and multiplications, Floyd Warshall, 0, 1, etc. But there are others also, like longest common subsequence. We can find a smallest also. There are different algorithms exist. So I hope everybody are able to see my screen and are we good? Just let me check the final time in the group. I can see seven people are watching. Just give me 1 minute. Okay, I think we're good, but I don't see the chat details. That is one thing. But yeah, Swati says hello sir. Okay, hey, hi. So I hope everybody are clear. So just ping me in the WhatsApp group or ping me in the comment section if you are facing any issue. But let me keep going. Okay. So we'll first So so before going to start this, so what is dynamic programming? I think we have already discussed about the greedy, right? So dynamic. So let me put the definition in the comment chat. Okay. So dynamic programming is a method for solving complex problem by breaking down into a collection of simple sub problems. So let me put it here. Okay, just 1 minute. So this is the definition. Okay. So we are given a complex problem. Okay. So generally we use. So this is one of the technique. So if you know, we have discussed. So dynamic programming is one of the technique. This is a technique. This is what? This is a technique, right? We know. So this is a technique. So this is a technique. So this, by using this particular technique, we are going to solve some of the problem, right? Like we solved that greedy using greedy, right? Using greedy, we can solve different problems, right? We have already discussed about different greedy approach, right? So similarly, dynamic programming is also another way of solving the algorithm or solving the problem in different word. So we will use dynamic programming so to solve any particular problem. Okay. So what is dynamic programming? Okay, dynamic, it is a problem of solving complex problem by breaking down a, suppose a problem is given, we'll break down the problem like in, okay, we'll break down that problem into small problems. Okay, the best part is, what is the main part actually? Main part is that whenever we are breaking that one into smaller parts, whenever we will formulate the solution of bigger part, we will keep this in mind of the solution of the small problem. Suppose I'll give a trouble. Generally, whenever we are going for uh, any solving any dynamic programming, then generally table comes into picture. Generally, okay, what does that mean? So that means whenever I am solving this particular whole problem, suppose I divided into 4 parts. Okay, 1, 2, 3, 4 parts. I'll keep, suppose the solution of this small part is 100 and this is 200. I don't know, means something. I'm just doing it randomly, 50 and 40. Okay. So I found the solution of this particular small things, and I will use this particular small part and find out the solution of the whole problem. Okay, so that's why, so it will consume little bit more memory. Why? Because it is storing the solution of each and every part. Okay, but which will be, or solution of each and every sub problem, which will be used in future to calculate the solution of the bigger problem. Okay, so that is the main idea of going for dynamic programming. Okay, so this will solve this small problem and keep it the solution of the sub problem, and which will be used in the latter part to solve the bigger problem. So that is the main idea of this particular dynamic programming. Okay, so you will get into know actually how, what is the approach and how exactly we are solving the solutions and small problems and all whenever we will solve this one problem maybe. So we'll start with LCS. I think you know the basic difference between greedy and dynamic. So that is one of the major things. Okay, so greedy does not give always the optimal solution, but this particular dynamic programming gives the solution, optimal solution every time. Why? Because we keep track of each and every sub problem. Okay, we solve each and every sub problem and find out the optimal solution and use the same sub problem's optimal solution to the bigger problem. Okay, so that's why it is giving, it will give, dynamic programming always gives the optimal solution. That is one thing. And second thing is that, but since we are storing all the sub problem solutions, right, whatever these small problems we are getting, we will store that one so that we can use that one in the future. Okay, so that's why it takes a little bit more time, more memory. So that is the one thing. It takes generally more memory. We have already discussed all the small points actually. So let's start with one problem so that you will be able to understand. So let's start with LCS. That means longest, what is the full form? Longest common subsequence. Okay, so what does that means? Longest common subsequence. Okay, longest common subsequence. Okay, so longest common subsequence. Okay, so we are finding a subsequence. So do you know what is a substring? You know, I think, what is a substring, right? Substring. Suppose given a string, so substring. I'm just writing substring. What is substring? Substring means given a string. Okay, given a string. Suppose A, B, C, D, E. So this is the given a string. So suppose I will tell that. So just I have written. So suppose F, C, D, M. Okay, these are the two strings. Okay, so tell me what is the longest, what is the substring of these things? Okay, what is the longest substring? Substring, I think you understood, but yeah, just I want to know what is the substring. Okay, so what is the substring? Can anybody answers what is the substring? So CD is the answer, right? So everybody are able to comment. I don't see much comments. So any problems or any issues? Yeah, CD. Okay, good. Okay, I got the answer. Okay, that's good. Okay. Yeah, CD, exactly. The CD is the substring. Okay, so that is the concept of substring. But if I ask what is the subsequences? Okay, what is the, forget about the longest one, we will go for that. What is subsequence? First of all, we need to understand what is a subsequence. Suppose it is like this. Suppose now tell me, okay, suppose it is like this. Then what will be the subsequence substring? Substring. If I ask substring, then there is only one match. If I'll ask substring, then what will be the substring for this particular case? For this particular case, what is the substring? Can anybody respond? What is the substring for this particular these two strings? What is the substring? Can you tell me? If this is a string one, this is a string two. What is the substring? Just tell me. Just write down in the comment section. C, yeah, that's correct. Yeah, means it can be either C, it is a substring because there is no other thing, or it can be D also, right? It can be either C or D, right? Because it is not matching, but C is alone matching. So this is a substring. If I will give in string 1, this is string 1, this is string 2. Okay, the substring for this particular thing will be either C or D, or D. Okay, now but we are reading, yeah, C or D, exactly, yeah, C or D. So but what we are reading today we are discussing about the subsequences. Yeah, right, C and D. So we are discussing about the subsequences. What does that means by subsequences? Subsequences, suppose these are two given strings are given. Okay, so if I'll ask what is the subsequences, then how it is going to calculate? So it is going to match this C to C. Okay, there is a matching. So first of all, no, it will start from F only. So it will find what is subsequence. Just try to understand betterly. So it will try to find out whether F is having any match. No match is found, right? So then it will try to find out what is the match with C. C is matching, right? Then it will search for M. M where? M in this particular string. So M is not having match. Okay. So then it will search for D. D is having any match? Yes, D is having one match. Then if somebody asks what is the subsequences between these two strings, then what is the answer? Answer is CD. Okay. Do you understand this concept? Means it is not like that it should be conjugative. In case of substring, it should be conjugative. You cannot skip any alphabets, okay, or you cannot skip anything. But in these subsequences, we are telling what is the longest common match between two strings, like this way. Okay, not like that they should be conjugative. Okay, so if just tell me, I will give one example to understand. Okay, so suppose A, B, M, C, D, E, F, C, M, D. Okay, suppose I'll write 10. Okay, just tell me the answer. Okay, just tell me the answer for this particular thing. So this is a string 1, this is a string 2. What is the common subsequences? Subsequences you understood, right? So this you need to just start with these things. So just keep on finding this particular alphabet in this particular sequence. It should not be conjugative. And given these two strings, this is another example. Okay, this is not example. Okay, example 1, this is example 2. Okay, just tell me what is the subsequences for this particular two strings. Okay, what is the longest common subsequence? We will go for longest part, but tell me what is the subsequence in this particular example. Just tell me in this particular example. So what is the subsequences? I will write another example. This is another little bit good example actually. Okay, anything should be fine, that's okay. Just write down for this one, we will get to know. But let me write out another example by the time you solve this one actually. Okay, A, B, C, D, A, B, C, D, E, F, G, H, I. Is it visible or not? Yeah, it is visible. A, B, C, D, E, F, G, H, I. Okay, and I, J, anything should be fine. Okay, so what I am giving, E, C, D, G, I. E, C, D, G, I. Okay, so if whoever have solved this particular example, just try to find out. So what is my question is, you can find also multiple subsequences. Okay, like you can find multiple substrings, like you had find that C and D were the substring, right? Substring. Similarly, you can find also multiple subsequences. Okay, just solve this particular thing and tell me what are the subsequences possible. Okay, so what was the answer? Whoever have solved example 2, just go for example 3. I will explain whenever I will explain, you can just give your attention. So just let me see what were the answer is. Okay, so just write it example. I just get confused. You have written, I think some folks have MD. Okay, AMD. Okay, Joylakshmi ma'am, she is telling CMDN. Okay, and what about others? MDN. Sasmita says MDN. Okay, that's okay. Let me write it down. Okay, Dharasiri says that CMDN. Okay, CMDN. She has told that same thing. CMDN. Okay, I can see lot of answer is having CMDN, but Sasmita is having answer MDN. Okay, let's have a look. what is the what is the answer. Okay, so just see. So what people have done, why there are two, I think we have only two answers. Let me see, there is just 1 second, guys. Okay, yeah, MDN. Smita madam says that it is MDN. Okay, means there are two solutions actually. Means according to your answer, there should be CMDN, MDN. Yeah, I can understand why that one. But let's try. Okay, so F is having not no match, so that's okay. But C is having one match, right? It is here. Okay, so C is having one match. Whenever we are coming to, so everybody have a confusion here only. Just look at, don't solve this now. Just have a attention here. Okay, just have a attention here. So there are two solutions given by all the students. So what is one solution is C. Okay, so F is not having matching, so that's okay. So whenever we are going for C, okay, there is a matching. Okay, so there is a matching. But whenever we are going for AM, okay, so then it is having a matching. So why there is a solution? Why there are two solutions? Because there is a matching here. Okay, there is a matching here. But the question is, I did not tell you, whenever you are going in this way, the arrow should not cross. That means this should not come before the string. Whatever has already matched, you cannot consider this part of sequence. Okay, so that means whenever you are drawing this kind of arrow, it should not intersect each other. That means whenever your CC is matching, you cannot take this M and compare this one with the previous substring. Okay, so that's why you cannot go backward. So this particular match is not possible. Okay, so that's why there was a little bit confusion. That's why people answered this M. Okay, okay, so this, so whenever you are going for C, then you cannot compare this MM, right? So then what will be the thing? Then there is a D is matching. Whether they are crossing each other? No, they are not crossing, they are just in forward direction. Then this is possible, right? So how about N is also matching. Okay, so this was one of the solutions. So what was the solution? CDN. Yeah, so nobody told about, I think, this particular solution, but this is one of the solution. Okay, CDN is MDN, I think people told, right? MDN. Yeah, MDN is also solution, but what I'm trying to say, CDN is also one of the subsequences. So for example 2, one of the subsequences that we got is CDN. Okay, then somebody can ask whether there can be possibility of any other subsequences. Yes, there can be possibilities. So suppose somebody start from, instead of starting from C, F we cannot start, that's for sure. C we cannot start. If somebody will start from M, we have a match here, we have a D match here, we have a N match here. Okay, so then what we can do, we can find MDN. So this is another solution. Okay, so what we see, but these two are having the same length. That's okay, that's okay, these two having the same length. But there is possibilities of, what I'm trying to say, there is possibilities of different subsequences. So whenever there is possibilities of different subsequences, our objective is to find out that particular subsequences which is having highest length or the longest length. So that is known as LCS, or longest common subsequences. Just find out the LCS or longest common subsequences for this particular thing. I think for example 2, I think you can take this one as the answer, or you can take this one, because both is having same length, right? So that's why this is okay. But how about this particular example? So I have given this particular first example, we got it clear, it is clear now. But how about the example 3? What is the longest? Just tell me two answers, just give me the two answer. What are the possible subsequences? Okay, what are the possible subsequences? Okay, and second thing is, well, what is LCS? Okay, so if you give this answer, yeah, just try to solve this particular example 3. Okay, so I think a lot of people have already solved and they are giving some answer. Okay, people are saying that okay, CDGI, yeah, CDGI, okay, that is one solution. Okay, yeah, so just write it down. Okay, so there, yeah, CDGI, tells, okay, CDGI, okay, EGI, yeah, right. So there will be, so if will be EGI and CDGI, so there will be two subsequences. So if I'll just say C, start from E, okay, So start from E. So if we'll start from E, then E is there, then C we cannot take, right? If whenever we are taking E, we cannot check because we cannot intersect, right? Then C cannot having don't have any match. If we'll take D, then D don't have any match. G, yes, it is matching. So if C, okay, sorry, E, G, then G is having a match, okay. And then how about I? I is having a match. So this is the first one. First one is E, G, I. So these are the, this is the first one. So first one is E, G, I. Okay. So if I will start from C, then instead of starting from E, then if I start from C, then what will be the match? C, D, G, I. Okay, so C, D, G, I, C, D, G, I. So this is number one, this is number two. Okay, then how about D? If I start from D also, I can get another subsequences D, G, I. Okay, so then if I start from G also, G, I, then also I can get a subsequences G, comma I. So I can get D, G, I. Okay, obviously if I get C, D, G, I, obviously I am going to get a D, G, I. I hope it is visible, and another one is GI and I also. Okay, so like I can get, what I'm trying to say, I can get multiple number of subsequences. Okay, so that is the conclusion. Okay, so if I get a number of number of different subsequences, then the question is which one is the largest one? Then this one is the largest one. Then if somebody asks what is the LCS or what is the longest common subsequences for this particular example, the LCS, you can write LCS for this example. This example is what is that? EDGI. EDGI, yes, EDGI. Okay, so EDGI. Do you got these things? So what is the subsequences? First of all, what is a substring? What is a subsequence? What is the longest common subsequence? I hope you guys understand, right? Now the question is now the question is, how can we solve? Okay, yeah, so then the question is, how can we solve this particular problem? Okay, using dynamic programming. Dynamic programming means we are going to use all the sub problem optimal solutions. Okay, so and we are going to store that one in some memory locations, and which we are going to use in future in order to find the optimal solution. So that's the question. So now I will take a small example in order to do this particular solve this particular LCS. I'll take a small example. I'm taking, suppose, BD as string 1, okay, and second string I will take as ABCD, okay, ABCD. Okay, just tell me what is the subsequence or what is the subsequences or longest common subsequences, what is the LCS. I think it is very much straightforward. But what is the subsequences? I think it is going to be BD, right? So because it is having every match, so this is going to match here. So it is the longest common subsequences. So LCS for this particular example is going to be BD, right? But the question is, how can I write a algorithm? How can I write a dynamic programming algorithm to solve this particular example? Okay. So generally, what we told, we'll solve the small program. Okay, we'll solve the small program. We'll keep that one in the memory. Okay, we'll solve a small program. We'll keep that one, and we'll use that particular solution in the future. Okay, so that is the main concept. So draw a table like this. So which is having how many number of columns? 3 number of rows actually. Okay, 3 number of rows. Okay, and 5 number of columns. Okay, so I'll tell you why this is like this, but that's okay. But just draw it like this. Okay, okay, 0, 1, 2. Okay, so just draw like this. No, not like this. Okay, draw a table like this, which is having number of rows as 3, 0, 1, 2, and number 5. So that means number of rows represent the string 1. So this particular rows represents the string 1. 0 means we are starting from 0th string if no string is there. So what is the length of this one? So this is the length of this one is 2. So this is the first string. So this is B. 1 means stands for B. This stands for D. 0 means no length. 0. Okay. So similarly, 1, 2, 3, 4 means just write it down A, B, C, D. Just above, just write it down like this. Okay. So then what we will do actually? So just think how exactly you are trying to do. Okay. So just think how exactly you are going to apply LCS. Okay. So that is the main thing. Okay. So how exactly you are going to sorry guys, yeah. So how exactly you are going to solve this particular example? Okay, so if whenever what you are doing actually, whenever you are trying to find out this one with this string, right? Whenever there is a match, whenever there is a match, so you are just making that one as output, right? If then again you are going for this and you are going for the second one, so the same thing you are going to achieve here. Okay, so then just tell me whether, so these things, okay, so these are 0 0 0 0, just put it 0 0 0 0, okay, because if there is no string then this is going to be 0 0. Okay, so these rows and columns are going to be 0 0. So I'll just write down the formula, but before write down the formula, let's deduct the formula. Okay, so we'll write down the what is the recursive formulation that generally a dynamic programming is going to use a formulation, recursive formulation. So that formulation we'll write it, but before writing that we'll solve this particular problem, which will deduce the recursive formula. Just tell me what it is telling. So what it is telling, just try to find out whether B is having matching with A. So it is now in this row and column, this is the I think there is a little bit confusion, sorry, just wait a minute. So there were 5 columns, right? Let it make like this. I hope it is clearly visible. So this is column number A, B, this is C, D. Okay, so this is 0. So let me put it 0. Okay, now tell me, so what it is telling, so if, so it is telling like this. Okay, so whether B is having match with A, whether B is having a match with A, answer is no. So there is no match. Okay, if there is no match, if there is no match, B is not matching with A, so what it is telling, okay, just try to find out, this is the column we are calculating, right? So this is the column we are calculating, this is the column we are calculating. That means suppose this is any matrix. Okay, so suppose this is matrix, suppose the name of the matrix is LCS, or you can give any name, A name. Okay, so LCS of IJ, suppose this is IJ. Okay, whenever you are calculating this one, if there is no matching, then you take maximum of this particular cell or this particular cell, that means left cell or the top cell. Then tell me what is the maximum, what is the maximum of this 0 and 0, that is 0, right? So just write it 0. Okay, okay, why you, if you will think why it is like this, so that means whenever you are at this cell, you are telling I cannot I don't have any match, so whatever the previous existing longest one is there, just return that one. So it is trying to say like that. Okay, so that's why just take, so I'll repeat that statement, whenever you are trying to find out the value of any cell, that means LCS of IJ, just see the left column or the top column. Okay, so left column and top column, and find out the maximum one. Okay, I'll write down also, so I'll write down LCS of I comma j. Okay, so which equal to, so this one equal to, so this one equal to maximum of, so the formulation if you'll write maximum of LCS of I minus 1 comma j. Okay, comma, so this is the first value. Okay, and second one is LCS of I comma j minus 1. Do you understand this one in matrix form? Okay, so what it is trying to say, maximum of I minus 1, I means row, right? Row minus 1, right? Row minus 1, column is same. Okay, so that means I minus 1, column is same, means this one. Okay, this one is, because I is what, I is 1 and j is 1 here. Okay, so I minus 1 means 0, column is same, so this one will be 0 comma 1, that means above 1, this is the above 1. Okay, first entry is the above 1, second entry is the same row, I is same row, but the column is minus 1, that means this one. Okay, so that means row is 0, sorry, row is same, 1 comma 0. I hope this is visible. Yeah, okay, so do you understand? That means whenever I am finding, suppose LCS of 1 comma 1, now we are finding, right, LCS of 1 comma 1, what I am trying to find out, so this value which is equal to maximum of 0 1 1 0, 0 1 means this particular column and this one means this particular column. Okay, so this part is clear. Okay, so this part is clear. So whenever I am trying to find out if there is no match, so this is for no match. Okay, I'll write down the algorithm, but this is for no match. Okay, so if there is no match, so then in that particular case we are going to find out the maximum between these two columns. Okay, sorry, these two cells. So the maximum between these two cells is 0. Just tell me how about this one. If there is a match b to b, so this is b, this is b, then there is a match. So what it is telling, take the value from the diagonal, don't take from above or left down. So take the value from diagonal and just plus 1. Okay, that means take this value from here and just add 1. Okay, so that means this value is going to be 1. Okay, so this value is going to be 1. Just 1 second, guys. Let me see which part is visible and how. Yeah, let me put it like this. Yeah, so what it is telling, yeah, what it is telling, just take the value from the corner, left hand side corner cell actually, and plus 1. So it was 0, 0 plus 1 is 1. Okay, so this is like this. So then the solution or the example or this particular thing will be, which is if there is a match. So this was the condition for if there is no match. If there is a match, so then what will happen, then 1 plus, if there is a match, so LCS of ij. Okay, I'll write it here. Okay, LCS of ij. So first condition, this was for the not matching condition. Okay, if there is a match, equal to 1 plus this particular cell. This particular cells means LCS of I minus 1 comma j minus 1. Okay, so this was the solution. So this was for if no match. Okay, so this was for match, if match match. Okay, so this was for if there is a match. I'll just repeat. I hope this notation is clear. So this is a array. I'll repeat it. This is array. Yeah, I am just trying to find out ij. If a of LCS means array, a of a ij you can write also, equal to maximum of this particular element or this particular element. Okay, so that means I minus 1 j or I j minus 1. And second thing is that if there is a match, that means b is matching, then take the corner one, take the top corner, left top corner one, means this one, and just add 1. Okay, 1 plus LCS of I minus 1 plus j minus 1, sorry, comma j minus 1. So I hope this particular thing is clear. Okay, so just now fill this particular table. Okay, so just tell me what will be the value of this one. Everybody tell me what will be the value of this particular cell. That means 1 comma 3. Just tell me the value of this particular cell. What is the value of this particular cell? Just tell me quickly. Just tell me quickly. Yeah, what is the formula we are going to apply? What is the formula? Just tell me the value of this particular thing. Yeah, what is the value? Just, yeah, 1. Okay, okay, that's good. 1 0, yeah, okay, 0 1 1. Okay, yeah, so yeah, the value will be 1. Why? Whenever we are calculating b and c, is it a matching? First of all, you need to say whether it is matching or not. Answer is it is not matching. B and c, it is not matching. Okay, 1, yeah, that's true. If it is a not matching, then what is our solution? Our solution is to take the maximum between this one, top one, or the left one. So maximum is which one? This one. That means 1. So I'm just going to keep it 1. Just tell me what about this one. You got it, right? So this much if you got it, so then we have the clarity. So BD, then it is not matching, then it is going to be 1. Okay, so that is as simple as that. Okay, now the question is, now let's try to fill the next row. Okay, next row, D is matching with A. Answer is no. Then what will happen? It will take the maximum between these two elements. Then what will be the value of this one? This is going to be 0, right? Then this is going to be 0. Then how about this one? D and B, is they are matching? No, they are not matching. Then it is going to be 1. Why? Because maximum among these two is which one? This one, 1. Then how about D and C? They are matching? No, they are not matching. Then maximum between this one and this one. Okay, so this one and this one, so this is going to be 1. Okay, then how about this one? Okay, so d D, they are matching. So what will be the value of this one? Just tell me the value of this last one. Just tell me the value of this one. Okay, so what is going to be the value of this particular thing? Okay, Just 1 minute, guys. Yeah, just tell me the answer of this one. Exactly, it is 2. But how it is 2? How it is 2? 2 is D and D are matching. So this formula is going to be applied. Okay. So D and D is matching. So then we are going to take this one from here. Okay. And plus 1, plus 1. So if there is a matching, so then LCS of ij is equal to 1 plus LCS of I minus 1 j minus 1. Okay. So then this is going to be 2. Exactly. Everybody given the correct answer only. That's correct. Okay. So this is going to be 2. Okay. So this is going to be 2. So this is the solution. So then, so finally, so just try to understand how exactly we use the optimal solutions or of the previous stored data. So that is very important. We'll go for these conditions and all. But see, whenever I am calculating this second row, okay, so then I am using the data of first row. So that is very important. That means I have calculated initially for first row. Okay, then I stored the value. That means I have solved the small problems for B as a subsequences. First of all, I started with B and I stored the data and I used the data, use all the data to find the solution for this particular row. Okay, so to find the solution for this particular row. Okay, so that's why suppose I have 100 lines, maybe if this subsequence I have given a small example, right? So suppose these are 100 subsequences, then what will happen? Then you need to write 100 number of columns, right? Then what will happen whenever you are calculating, suppose 20th number of rows, then you need to use the data that is already stored in the previous row, because you are finding it from the previous this above or side one. Okay, so that's how you are going to formulate the details of the LCS algorithm. Okay, so this was just a small example. Okay, I'll just give a small assignment. Okay, you can try at your home. Okay, and you will just let me know so what is the common subsequences but using this particular theory. Okay, not by looking at it. Okay, so that is like, well, write down the example. Okay, a small example. Okay, so that you can try. Okay, STONE. So this is longest. Okay, so these are the two substrings. Just try to do it. Okay, so just try to do it. Okay, so then you will able to see. Just let me know the answer using this particular thing. Okay, so I think the algorithm will be, so just tell me what will be the algorithm. Okay, so I think algorithm is very straightforward. Okay, so what you need to check, if there is a match, so then you need to return this particular thing. If there is no match, then this is going to return this particular thing. Okay, so this is how the LCS behaves. Okay, so the time complexity wise, okay, let me tell you the time complexity wise. So just tell me what will be the time complexity for this particular algorithm. Okay, so what will be the time complexity? I think what exactly we are doing, it is a matrix, right? What we are doing in this particular example, if you'll see, we are just trying to fill this particular matrix, right? So this matrix is having size m cross n. Okay, so m cross n, suppose this particular first rows is, I don't know the length, so suppose they are variable, so m cross n, then I'm just trying to fill up this one. So I'm just trying to fill up this one. So filling this one is a constant time, you understood, right? Because I'm just filling this one, because I'm taking either this one or this one, so this is a constant time, this or plus of this. Okay, so this is how I'm just formulating. Okay, so that's why the time complexity of this particular algorithm is theta of m cross n. Okay, so this is the time complexity, because I'm just trying to filling this particular table. That's all I can say. That's all, I'm just trying to filling this particular. So whatever the algorithm I have written or this particular thing they are doing, so they are just filling this particular table. Okay, so I think I was just about to erase, but just tell me, I just should draw this table, but how about the subsequences? We had taken this example, right? BD ABCD. So this example we did, actually we missed one thing. Just tell me, I think you had written this one. So our example was like this, right? BD ABCD. But the question was, it was a small example, you can looking into, you can stay, but the thing is, you have drawn this particular table from this particular two substrings, right? And the question is how to find what is the longest common subsequence. Okay, how to find? So what is the solution? So what is the solution here? Here the solution is BD, right? BD. But from this table, how can I find? I hope you have written all these things. Let me erase it, okay, so that we'll have some space. Okay, but the question is, I have only my this table, but how can I get BD, or how can I get the longest common subsequences from this particular table? Okay, so I will start with this particular thing. Okay, I will start with this. Okay, I will start with this and trace back. Okay, so trace back to get the subsequences. Just tell me how these two came. 2 came from this 1, because this is not coming from these two, right? So this is not coming from these two, because if you could have come in from these two, then it is the maximum among these two, which is 1 or 1, that should be 1. So since it is 2, then definitely it is coming from the corner. So just draw a line like this, and whenever there is a, just draw a line like this. Okay, and how about this 1 is coming from a corner, or this one, it is coming from this one, right? Because maximum of these two. Okay, so maximum of these two, so this is coming from this one. Okay, how about this 1 is coming from these two? No. Maximum of these two? No. This is coming from there, from the corner. Okay, so just see, and after drawing this particular arrow, so what we will do, whenever there is a arrow, just print that. That means, if you'll say arrow means what, that means if there is a match, then only you had drawn an arrow, right? In the, if you remember, if there is a match only, then you are taking it from the corner and adding it 1. So that's why if there is a this corner arrow, just print it. So this is a D, this was D. Is there a corner arrow? No. Is there a corner arrow? Yes, it is here. So this was B. So this is the common subsequences in this particular example. Okay, so this is the LCS for this particular example. Okay, so I hope you understand. Store or stone, Sati? Store or stone? Sorry, what exactly we are storing? No, there is no stone, so we need to store only. Okay, so what I'm trying to say, so start with this particular thing. If there is a match, that means 1 plus 1, so it is coming from the corner. Just put this arrow from where it is coming actually. Okay, so and after that, what you will do, whenever there is a corner arrow, because corner arrow is that time whenever there is a match, right? Whenever there is a match. So this B and D. So this is the solution for this particular example. If it is a big example, then you will start this one. Just whenever there is a corner arrow, then just print it that particular variable. Okay, so that is all about it. So let's yeah, so the time complexity wise, it was order of m cross n, because it depends upon the matrix. We are just doing a matrix evaluation, so nothing more. Okay, and if you want to write the program, so or algorithm, you can write it. Okay, so this is also very straightforward, whatever we have written, so that is the same case. But yeah, let me write it quickly. Okay, so it is going to return something. Okay, integer means it is going to just return what is the length actually. Okay, so I'm taking ij. Okay, so if suppose a of I equal to fj. Okay, so if there is a match, if there is a match, oh, okay. Oh, you have solved the assignment. I just surprised. Wow, where the stone is come into picture. Okay. I don't know the answer, but yeah, that's okay. Okay. I was thinking, where is the store or stone? Okay. So that was actually a stone. 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 Okay. Stone and longest. Longest. Okay. Okay, so that was the assignment. Okay, stone, stone. Yeah, stone. That's okay. Stone only. Okay, longest. Okay, So I was just writing the algorithm. So if there is a match, okay, then what I need to call? So if the means elements are matched, then what I need to call? Then I need to add one. You remember 1 plus LCS of what we are doing? I minus 1, j minus 1. That we are doing, right? We are taking from the corner. If there is a match between the element, right? So that we will write LCS. Then we will call the same method, actually same recursion, I comma j. Okay, so we are going to call the same function by using, but with different parameter, right? LCS of LCS of LCS of LCS of 1 plus, actually 1 plus LCS of I minus 1 comma j minus 1. Okay, so this is the method. Okay, so this is the I1 plus LCS of I minus 1 comma j minus 1. Okay, so this is the case whenever we are getting a match. Okay, so if there is a no match, that means it will come in the else part. That means there is no match. That means elements are not matching. In that case, where exactly we will take? If there is a match, you are going to take it from here. If there is no match, you will take it from either here or here. Okay, so you will take either here or here. You will take the maximum one. If there is a match, you can draw a picture like this also. Okay, just draw a picture maybe like this. Okay, so just it is coming from here. It is coming from here. If there is a match, but it will come plus 1 as plus 1. Okay, so draw a picture like this. If there is a match, it will come from here. Then if there is no match, so then this will come from here. This is maximum. The maximum of this is going to be here. Okay, so this if no match, if no match, just draw this particular picture, so that this is for your reference. Okay, I just draw it myself. So just think about this way. If there is a match, plus 1, whatever is coming, plus 1. If there is no match, just take the maximum one. So this is the algorithm. Okay, so I think you had written this one. So just yeah, so else part, else if else LCS of I comma j equal to, I am erasing this part. Okay, erasing this part, I comma j equal to LCS of I minus 1 comma j, maximum of, actually maximum of comma LCS of I comma j minus 1. Okay, so this was all about this one. This is the algorithm. Okay, so this takes order of m cross n. Okay, so this was all about the all about the matrix, LCS. Okay, I hope you have written. So I will just give 1 second. If there is any quick queries, or else we'll go for the next algorithm. So the basic concept is what I'm trying to say. We are going to use, we have used a matrix to store the previous result or the sub-problem result which we have used in the next solving the bigger problem. Okay, so that was all about the LCS. Okay, if there is no question, so we'll go ahead. We'll go for next. I'm just erasing this. Okay, so we'll go for the next problem, which is matrix and multiplication. Okay, matrix and multiplication. Okay, so matrix and multiplication. Okay, so before going to matrix and multiplication, so we'll start with the matrix multiplication. Okay, matrix, just make it ready. Matrix chain multiplication. Okay, so before understanding what is matrix and multiplication, we need to understand. We'll go for that in details with the algorithm and how to solve. That's okay. But before going for MCM, matrix and multiplication, so let's understand what is the matrix multiplication. Okay, so so just tell me, when can I multiply two matrix? Suppose A1 is a matrix, A2 is a matrix. Okay, there are two matrix. Then the question, there is some condition. In which condition I can multiply? So matrix means it is having some dimension, right? 2 cross 3. So this particular thing is 3 cross 4. Okay, so something like this, right? So can I multiply these two matrix? So I am given to example 1, example 2. Okay, same A1, A2. Okay, so this is having size 2 cross 4. This is having 3 cross 4. Okay, then the question is, question is, I have given example 1, example. Then the question is whether I can multiply this example 1, whether I can multiply example 2. Answer, give me answer. Whether I can example 1, example 2. Whether I can multiply these two matrices in example 1, whether I can multiply this particular two matrix in example 2. Whether answer, give me answer. Example 1 correct, example 2 correct, or example 1 wrong, example 2 wrong. Just tell me the answer. Example 1 correct, example 2 correct, or something like that. Give me the answer. Just 1 minute. Okay, so I got some answer. Okay, example 1, second not Smita ma'am. Okay, Jalakshmi. Okay, Swati. Okay, example 1 we can multiply. Example 2 wrong. Okay. Yeah, exactly. Example 1 is quietly possible. Okay, example 2 is not possible. Okay, so why it is like this? Because we know in order to multiply two matrices, the column must be same. This particular column, this particular rows, the column of the first matrix and the rows of the second matrix is going to be same. So that's when we can multiply two matrices. Why? Because we know, right? So this particular, this is going to be multiplied with this, right? Generally this is like this, right? So that's why it is like this. Okay, so then this particular thing we can multiply, then this one we can't, because this 4 is not same as this one. So this is the first thing. Okay, that's example 1 can possible. Okay. Okay, I did not get the response from Sasmita. Sasmita, I hope you understood about this particular two matrix when can be multiplied. Okay, so apart from this, everybody are good. Okay, so two matrix can be multiplied if this one and this one are same. Okay, so otherwise I cannot multiply, because this column must be equal to the number of rows. Okay, so why so? Because, and this is not possible. Answer is this is possible, this is not possible. But why it is not possible and possible? So if you know, so matrix how generally we multiply, if you know, so that is the simple fundamental, right? So suppose 2 3 4. Okay, so suppose this is a matrix, suppose this is 8 9 2. So this must be same. So this, because 2 is going to be multiplied with 8, so that I am not concerned about these things. Okay, I am not concerned about what is there, others are there. But what I am concerned, if there are 3 elements here, there must be 3 elements here. 3 elements means this is column, right? That means if it is a 2 or 2 cross 3, I am not bothered about x. It means it is m cross 3, then this must be n 3 cross n. Okay, so this must be 3 cross n. That means number of rows must be this one, because they have a one-to-one correspondence between these two, because 2 is going to be multiplied to this, plus 3 is going to be multiplied to this, and 4 is going to be multiplied to this. If I put a 2 element, then what about the third one? Then it is not possible, right? Then definitely what is my assumption? Whatever the number of column in the first row must be equal to the number of rows in the second matrix. Okay, so that is my conclusion. Okay, then tell me, then now I think you got this particular thing, right? Then write down a question. What is the number of question? Just write down a question. Number of scalar operations needed. Number of scalar operations needed. Number of scalar operation. Okay, number of scalar multiplication operation, actually you can write. Number of scalar multiplication operations needed to multiply a n anything you can write, m cross n matrix to a n cross p matrix. What is the number of scalar multiplication needed to multiply m cross n matrix with the n cross p matrix? Just tell me the answer. You understand, right? My question is very simple. So we are doing some multiplication. I showed you, right? 2 3 4, some matrix is there, and suppose this is 4 8 9. Okay, something. Okay, so I need to multiply this one to this one, this one to this one, this one to this one. Okay, So then I will get it. Suppose this is a 2 cross 3 matrix. Okay, so suppose this is a 3 cross 4 matrix. Then what is the output? First of all, okay, so Smita madam says M cross P, N cross P. Okay, anybody is having another answer? Just tell me. Okay, but in the meantime, this is visible, right? Yes. M cross P. Lakshmi madam says okay. Swati says N cross P. Okay, that's okay. So then the okay, just let me. You people first tell me. Then I think I will write it down since you are calculating. Just tell me. Yeah, number of scalar multiplication operation performed whenever I am multiplying a M cross N matrix with a N cross P matrix. Swati says sorry, M cross P. That's okay. I'll just give one minute, more minute maybe. Just yeah, but whatever you are telling, everybody are wrong. Maybe if you want to try once again, so everybody are wrong. Just try a little bit more once, and just maybe 1 minute. Okay. So yeah, the answer is not correct. So whoever is given, so there is a little bit tricky is here, but yeah, that's okay. But that's a nice try. Yeah, I'll just maybe tell one more thing. Just think in this way, so that you will able to understand. Just think in this way. So you are having a, so this is a M cross N matrix. Just think about 2 cross 3 or M cross N. So this is a, is it visible? I don't know. So this is a M cross N. This is a N cross P. Okay. Then you are getting a, suppose this is a matrix A1, this is a matrix A2, and this is matrix A3. So then you are getting this matrix, right? So this I don't know, means suppose 2, 3, 3, 4 means this is going to be 2 row and 4 columns. So you are getting these things. Okay. So in order to get one element, what is the number of scalar operation is needed? Okay. In order to get a solution, this is the solution, right? You are getting each element after doing some calculation from these two, right? Just think about what is the number of multiplication needed for one element. Then how many elements are there? Think in that manner. I just giving a hints. That's okay. You can think in your way also. But yeah, so this is a 2 matrix are given. So I'm just trying to find out the third matrix. Okay, then what is the number of scalar multiplications? I'll give 1 minute, 1 more minutes to think about you. Okay, so I think that's okay. So I think we have yeah, we'll yeah, let me see. Okay, so we are getting some different answer, 2 cross 3. Okay, yeah, so the answer is okay. I'll tell the answer maybe. Okay, so it is going to be M cross N cross P. Okay, so this is the answer. If it is a 2 cross 3, 3 cross 4, then the answer is going to be 2 cross 3 cross 4. Okay, so this is the answer. Okay, just try to understand. I just erase it and make. Okay, just think about it in this way. So in order to so just think, so this particular element is going to be multiplied how many times? Okay, so in order to get in this one row, okay, so in order to get in this one particular element, so you are doing so this many number of operations. Okay, how many number of operations? Okay, how many number of operations you are doing? For getting one row or this one, so you are this is the number of columns, this is the number of rows. Okay, so this is the number of columns, that means n, right? And this is the number of rows, right? You are multiplying this one, that means rows means n, right? So you are doing a n operations, and you are doing it for every columns, right? And for every rows. So for m rows, you are performing n columns for each and every columns. To get one element in this particular C matrix, you are multiplying this one with this one, this one with this one, this one with this one. That means you are doing m cross n number of operations, right? M cross n number of operation, because 2 into 3, and you are doing for whole thing. That means p number of column for all columns, right? So that's why it is going to come as m cross n cross p, m cross n cross p. Okay, so this is the number of operations. This is the number. What is this? This is the number of operations, number of scalar operations or multiplications. Okay, multiplications we get to perform. Achha, we have written the question to perform the multiplication of two matrix. That is number of rows into number of columns into number of columns in the second matrix. Okay, so because we are taking each and every element, whenever we are getting this, we are doing a scalar multiplication here, and we are doing it for every row, right? And we are getting it for everything, right? So that's why it is going to be m cross n cross p. So that means, suppose I am given, suppose somebody will ask, okay, in general this type of question comes, what is the number of questions? So 2 cross 4 matrix is given, 4 cross 3 matrix is given. What is the number of operation is possible? What is the number of operation? So that is possible 2 cross 4 cross 3. So this is the number of operations or number of scalar multiplication operations. Okay, so this is the number of operations is possible. So this is all about one matrix multiplication. So suppose you are given a matrix and you are performing this matrix, but we are not interested in matrix multiplication. We are interested in matrix chain multiplication. What does that mean? There is a difference, right? Matrix multiplication means we are just multiplying two matrix, A and B are two matrix. So then we are trying to multiply this one. But our objective is to matrix chain multiplication. That means there is a series of matrix. There is a series of matrices there. Okay, so we are trying to multiply this. Actually, in matrix chain multiplication, we are not also multiplying. What we are trying to do, find out a way of. We are just finding out a way of multiplication. Way of multiplication. Okay, in which the number of, in which we are finding out a way of multiplication in which the number of operations, operations means this multiplication operation, or you can write multiplication operations, is minimum. We are finding out a way. What does that mean? But then the question is whether there is a different way. Answer is yes. Suppose A, B, C is there. Okay, so suppose A, B, C is there. Okay, and tell me what are the different ways of multiplying A, B, C. Okay, so I can multiply. Then the question is, I think I had another question. Okay, that's okay. So suppose there are three matrices A, B, C are there. Okay, then the question is, what are the different ways of possible of multiplying these three matrices? Then I can do, first of all, I can multiply A to B, then I can go for C, multiplication with this C, or else what I can do, A, then B, C. That means I can multiply B and C, and then I can go for multiplication with the matrix A. Okay, so this is how I can go for it, right? But the question is, but before going to this, just tell me whether A cross B is same as B cross A. If there are two matrices, okay, A cross B is same as B cross A. This is the question, whether A cross B is same as B cross A in case of matrix operations. Okay, so whether A cross B is B cross A, just tell me the answer. Okay. Answer is no. Yeah, right. That's true. Because we know, right? Matrix multiplication is not commutative. Okay, that's okay. Answer is no. That's straightforward, right? Because if it is a matrix of 2 cross 3, so if you'll see, if it is a 2 cross 3, it is a 3 cross 4, suppose. Yeah, answer is no. I cannot multiply this matrix with this one, right? Because this is having 3 cross 4 and this is having 2 cross 3. And first of all, this must be matching, right? If I take this one there, this is going to be 2 cross 3. Okay, this was A matrix, this was B matrix. So B cross A, if I'll do, so they are not matching. Then I cannot multiply. So obviously this is not going to be same. So that was one thing. Just wanted to make you clarify. That's okay. But the question is now, if I multiply, there are three matrices now, right? Three matrices A, B, and C. A, B, and C. Then the question is, if I do AB, if I multiply AB first and then I multiply C, okay, or else if I multiply BC first then multiply A, whether the number of operations, are different, number of operations are different. This is the questions. The number of operations, whether the number of operations are different, whether the number of operations, whether the number of multiplication operation, or you can write also operations. That's also fine. Okay, that's not a problem. But the question is whether the number of operations are different. That is the question. So can somebody answer me whether there are two options? There are given, question is like this, given A, B, C matrix. Okay, there are three matrices given. So I am just putting a bracket here. I am not doing nothing much. What I am trying to say, I will just multiply A and B first, then I will go for multiplication to matrix C. In the next scenario or the next case, I am going to multiply this particular B and C matrix first, and then I am going for the multiply the A matrix. Okay, so then there are case 1, this is case 2, this is case 1, this is case 2. Okay, then tell me, so whether in the both situation, or both the scenario, in both the scenario, whether the number of matrix operations are different or not. Answer is yes. Okay, Smita madam says it is yes. Okay, then the answer is yes. Okay, now tell me what is the number of operations in this particular case and in this particular case. Just calculate it and tell me. In case 1, just tell me that like this. Case 1, the number of operation is 100, 200, I don't know. It is like this. And in case 2, the number of operation is like this. So if you don't know, I think you know, right? What is the number of operations? So suppose A and B is 2 cross 3. So suppose this is 2 cross 3, this is 3 cross 4. Take an example. Okay. Suppose 2 cross 3, 3 cross 4, then the number of operation is going to be 2 cross 3 cross 4. Okay, so 2 cross 3 cross, this is the number of operations. So in the simplification, in this example, let me write it like maybe if you are not getting what is the size of this particular 2 matrix, maybe I will write it. Suppose this is 2 cross 3. Okay, so this is 3 cross 4, and this is C is 4 cross 5. Okay, so this is the dimension of any particular matrix is given. A matrix is having size, or the dimension is 2 cross 3. B matrix is having dimension 3 cross 4. C matrix is having dimension 4 cross 3. Just tell me what is the number of operations in case of case 1 and case 2, and which one is the maximum. If you find the number of operations, then that's fine. I think we can find the maximum. That's okay. It's not a big deal. But just find it quickly. Yeah. For case 1 and case 2. See, the size is given like this: 2 cross 3, 3 cross 4, and 4 cross 5. Okay. I'll just give 1 minute, more minute, solve everyone. Is it done? Okay. Okay, maybe 1 more minute maximum. So you got the question, right? Case 1 is 3 matrices are given. So I want to multiply these 2 matrices. So suppose I will tell that what is the number of operation for A to B, A cross B. So then it is going to be these 2 multiplied, 2 into 3 into 4. So that is how much? I don't know. And then whenever it is you are doing a multiplication with this, okay, then you need to add that thing. Let me do you. Yeah, 24 and 18. Okay. Yeah, so let me first maybe. Okay, everybody, so you have tried actually. So then yeah, 164, I don't know the answer also, but let us first try to understand. Okay, case 1. Okay, let's try to first of all formulate the case 1. What is the number of operation? What is the number of operation for case 1? Case 1 means this one, right? This one means A cross B cross C, right? So this is like this, right? So this is like this, A cross B cross C. Okay, so A is having, so maybe I will write it down here, 2 cross 3, B is having 3 cross 4, and C is having 4 cross 5. Okay, so I will have some space. So this is the case 1, is case 1, case 2. We are trying to solve case 1. Okay, so the number of operation needed to multiply these two, A and B, is, so first of all let's solve. So this is the case 1, A cross B cross C. So for A cross B, we know what is the number of operation? 2 cross 3 cross 4. 2 cross 3 cross 4. But one thing I just want to say, after finding A cross B, what will be the dimension of this matrix after multiplication? It is 2 cross 4. Everybody understood this or not? This is very important point. Just focus. A, B given matrix is there. So I am trying to multiply A and B. Okay. So after multiplying A and B, so I will be getting. So what is the final dimension after multiplication? This matrix I will be getting one dimension, right? So that is 2 cross 4. Do you understand this? Because do you understand this, that I am going to get say 2 cross 4 matrix whenever I am multiplying a 2 cross 3 matrix with a 3 cross 4 matrix, then I am going to get a 2 cross 4 matrix. Do you understand these things? If yes, then I am having a 2 cross 4 matrix here and C matrix. C matrix is nothing but C matrix is 4 cross 5. C matrix is 4 cross 5. It is given, right? 4 cross 5. Then the question is, so for to do this operation, I need this much. That means 24 plus. In order to multiply these two matrices, because I am having a suppose matrix something after doing multiplication A to B, then I am having a matrix of size 2 cross 4, and I am having a matrix C which is having 4 cross 5. Then what is the number of operations? Now 2 cross 4 cross 5. Okay, so which is 40. Okay, 40. So the number of operations needed for to multiply A and B was 24. The number of operations needed to multiply the output of this matrix and this matrix was 40. Okay, then the total number of operations needed to do this is equal to 64. So who had written 64? Case 1, Swati. Okay, 64. Okay. So do you understand this? Okay, there is a lot of no. But what was the question? Okay, so do you understand this? Just write down yes or no. So I'll tell you once more, maybe. So to multiply, okay, just let me clarify. Just let me clarify one thing. Okay, because this is the very important concept. If you understood this much, then matricial multiplication is going to be over in 10 minutes. That's not an issue. So that's a easier part. So just let me know if there is a cross B is there. Okay. So the number of operation is 2 cross 3 and 3 cross 4. So but the size of the matrix of A is 2 cross 3. The size of the matrix is 3 cross 4. Okay. Then the number of operation is 2 cross 3 cross 4. That is the number of operation. But what is the output of this particular matrix? I will generate another matrix, right? If I multiply these two matrices, I will get a matrix. But what is the dimension of these two matrices? Tell me. What is the dimension of these two matrices? Means what cross what? Just tell me. So this you need to answer me. If I multiply a matrix 2 cross 3 into 3 cross 4, then what I'm going to get another matrix. That is for sure. We know. But what is the dimension of this particular matrix? That means what cross what? X cross Y. What is the value of X cross Y? What is the dimension of X cross Y? This is the example. Forget about all these things. My questions, I'll repeat the question. A, B matrix are given. A is having 2 cross 3 dimension and B is having 3 cross 4 dimension. We are going to formulate another matrix which is D. After multiplying these two matrices, which is known as D, it is having some length or some dimension, which is X cross Y. Tell me the value of X and Y. Just tell me the value of X cross Y. Yeah. Tell me the value of X cross Y. Quick. I think Swati says 2 cross 4. Okay. Sasmita says, okay, 2 cross 4. That's correct only. Yeah. How about others? Smita ma'am, Jalakshmi ma'am, Dharasri. Some people are sleeping after the exam. Okay. 2 cross 4. That's good. Okay. Okay. That's okay. So yeah. So do you understand that everybody must understand this 2 cross 4? So whenever I am multiplying these two matrices, then it is going to be 2 cross 4. Okay, so this is very important concept. If not, then you can try. Yeah, 2 cross 4. That's okay. And so you can just try. Take a 2 cross 3 matrix and multiply it with a 3 cross 2 matrix, 3 cross 4 matrix. You will get a result of 2 cross. Number of rows is 2 and number of columns is 4. Okay. So this part, if you are getting clear, now just tell me what is the number of operation for second case? I think everybody answer. Now second case. The second case. Case 1 we have calculated this one. Okay. So first, how case 1 you have calculated? You have calculated the number of operation for this. So you have written at 24 plus. So what are the number of operation? So what is the dimension of this into dimension of this? So this is the number of operation to multiply this one and this one. So total number of operation this plus this. Okay. So which was 64. Okay, sorry, 64. So then tell me what is the number of operation needed for this particular sequence. Whenever I am doing, first of all, I will multiply B cross C, then I am going to multiply A. A lot of people has answered. 60 case to 90. Okay. Any other answer? 120, 30, 40, 60, 70, 80. Any other answer? Quick answer, or else we will go for the calculation. So that is basic simple calculation, but you need to be very much clear before going for, because this is how we are going to apply the matrix multiplication. 90 is 90. Okay, Jayalakshmi, can you calculate it once again? 60. I don't know the answer also, by the way, but since a lot of folks are telling 90, so that's why I'm assuming it should be 90. I don't know. We will calculate it here. Yes, Smita madam says it is 90. Okay, that's okay. Okay, let's calculate actually. Okay, let's calculate. So there are two things. Let's calculate this particular situation. Okay, this was the our question. Okay, so the number of operation. So because generally they ask in the question, generally they ask typing mistake. Then that's very good. If it is a typing mistake, then that's okay. So the number of, I'll just repeat it quickly. Okay, so the number of operation is m cross n cross p. So that is 3 cross 4 cross 5, right? Then 3 cross 4 cross 5. Okay, so this is the number of operation. No, not plus. This is cross. This is 60. So 3 cross 4 cross 5, which equal to 60. So this is the number of operation for this particular thing, and I am having some operation. But what is the dimension of this particular matrix? This is very important. What is the dimension of output matrix of this one? So this is going to be, I'm rearranging this, 60 plus something will happen. This is going to be 3 cross 5. Okay, and however this 2 cross 3. So now I am going to multiply a 2 cross 3 matrix with a 3 cross 5. Okay, so this is going to be 60. So initially the number of operation needed to complete this particular operation for multiplying these to B and C is 60. Then to multiply these two matrix, so it is going to be 2 cross 3 cross 5, which is 30. So 60 plus 60, 60 plus 30, which equal to 90. Okay, so this is 90. So what was the conclusion? The very important thing. I hope this part is clear. If this part is clear, matrix and multiplication is over. Now we don't have to do anything much more. We have to just write down the algorithm. Okay. So little bit you need to have lesson, but that's okay. But the question is, but the understanding is, but one thing to observe. Okay. One thing to observe. Okay. So what is the thing to observe? The matrix was same, right? ABC. Case one was this, case 2 was this. Okay, so the matrix both situation, the matrix was same, right? A, B, C, and the solution you are going to get, if you multiply, then this is going to be same, right? Because it is a multiplication, it is not going to be different. But the number of operation in the first case, that means if you first multiply A to B and then B to C, then number of operation is 64. This was a small matrix, that means 2 cross 3, just a small matrix, the C. But in case of, but whenever you are going to multiply B cross C first and then A, then you are going to number of operation as 90. Okay, just one second, guys. Yeah, number of operation as 90. Okay, then the question is, then the observation is, then it completely, the number of operation is depends how you are putting the parenthesis. That means which two matrix are being multiplied first, and then which matrix we are taking second. So that is the very important point whenever you are going for matrix and multiplication. Okay, So that means the placing of the parenthesis plays an important role in case of matrix and multiplication whenever there the number of matrices is more than 2. Okay, so this is a small dimension. I just took an 2 cross 3 or 3 cross 4, right? But if you take a large dimension in real world that we are going to use, which is a 100 cross 250, something like that, then the number of operation is going to be in millions. There is a difference, is going to be millions. In that particular situation, matrix and multiplication plays a very high vital role. So matrix and multiplication tells what? It does not multiply the matrix. No, it is not going to multiply the matrix. But what it is going to do? It is going to give you a solution. That means first of all, multiply these two matrices first or not. Solution was this one. So it will give you an output that multiply these two matrices first and then multiply this one, which is going to give a better solution. Okay, so that's why matrix and multiplication plays a very important role. So this was all about this one. Okay, so yeah, let's take an example. Okay, so yeah, so this was all about the matrix and multiplication, but we'll discuss a little bit further. Just write down one thing. Okay, just write down one thing. One formulation. We'll understand what is this formulation is all about. But whenever we are calculating the matrix of any ij, okay, what we are trying to do, okay, just write it down. Okay, if I equal to 0, okay, so if I am trying to calculate the matrix multiplication for I and j, m of I of j, okay, so this is going to be 0 if I equal to not 0 actually, I equal to j. If both are same, then there is no, we are not going to having any multiplication. Okay, so or else minimum of I less than equal to k less than equal to j, okay, less than equal to j, okay, actually less than j, m of I j m of I j plus k plus 1j and okay, m of, no, you can write like this, m of I k plus m of k plus 1 j, okay, plus p of I minus 1 pk pj, something like this. We'll understand what are these things, what are these terminologies, but that's okay. Okay, so but that's okay. But just write it down. Okay, so what it is telling, so just think about this one, a1 a2 a3, it was there, right? Three matrices was there, right? So if that is the situation, so this was having some matrix 2 cross 3 2 cross 3, this was having 3 cross 4, this was having 4 cross 5. Okay, so this was the solution, right? Oh, so this was the given matrix, something like that. So suppose I want to multiply, I want to make a parenthesis between these things. Okay, so what it is telling, just try with all the possible solutions. So suppose I is 1 to 3. What I'm trying to say, I want to find out a solution 1 to 3. Okay, so then you just try to see what are the combinations. Okay, this is the combination, so this is the combination. Okay, just try to find out. Okay, find out all the possible solutions. Like what was the solution, suppose in the previous case, so like we had taken two examples, right? A1 a2 a3. I'm just giving an example, we'll understand that betterly. A1 a2 a3 or abc, that was ab3. I hope it is visible. Let me see if it is visible or not. Yes, small part is visible. Okay, so we have two situations, so we are getting a better solution, this one. Okay, so that is same thing it is telling. So whenever you are multiplying two matrices, what generally we do whenever you are multiplying two matrices, suppose a1 and a2. So let me explain you. So suppose ab, there are two matrices. Okay, I hope you have written this one, I'm just erasing this one. Suppose ab is there, so a matrix is, suppose A and B is there. A is having 2 cross 3 and this is having 3 cross 4. Okay, two matrices is there, right? So what I'm doing, So this is so whenever I am finding m of ij, just 1 minute guys. Sorry. Yeah, whenever I'm finding this particular 2j, so what I'm doing, I'm trying to find out m of ik. Okay, m of ik means multiplication of the smaller part. So suppose so you have seen that one, right? So a cross b, so this was a cross b, this is c. So I will try to find out this one and this one. What is the operation needed for, suppose this was c cross d. So what is the number of, I'm just telling overview. Okay, we'll see the details. So what is the number of operation needed for a cross b? Okay, and what is the number of operation needed for c cross d? So we just add them, right? So if you remember, we were adding it, right? So this one plus this one, right? This one plus this one. So what is the number of operation needed for this one? For this one, okay. And again, whenever I am performing any matrix multiplication, suppose I am multiplying these two, then suppose the output, then if I'm getting output, the number of operation for this one plus number of operation for this one, again if I multiply this, suppose the output is 2 cross 3, 3 cross 2, then I will get 2 cross 3 cross 2, right? So plus this one, that means m of ik plus kj means whatever the number of operation needed for individually, whatever the number of operation needed for individually. Again if I do multiplication, then I will get, right, some dimension plus some dimension. So this is nothing but pi pj pi minus 1 pk pj. Okay, so then that is the solution. Okay, I hope you understood this. If not, just look at this. Okay, so suppose this is a matrix, I'm getting something, some operation. After getting suppose 100 operation, I'm getting this matrix. Okay, so suppose after getting 200 operations, I'm getting this. Okay, so 100, then what will be the total number of operation? That is 100 plus 200. Then again I need to form the final matrix, right? After this, so this is 2 cross 3 and this is 3 cross 4. Then 2 cross 3 cross 4, 24. Okay, then 100 plus 200 plus 24. So that is the solution. You got it, right? How means what I'm trying to say, part of a solved problem, left sub problem, part of the right sub problem, plus whatever the number of things needed to combine these two sub problems. So that's how this particular formulation begins. So maybe if you don't understand, then let's calculate this. So I hope you understand some part, but yeah, if not, then let's try to do an example so you will get a clarity. Okay, so how exactly we are going to use that one. Don't worry. So I am giving a 4 matrix, A1, just write it down, A2, A3 and A4. There are 4 matrices having some dimensions. So suppose this is 5 cross 4, this is 5 cross 4, okay. So 4 cross 6, this is 4 cross 6, this is 6 cross 2 and this is 2 cross 7. Okay, so this is how the matrices are given. Okay, so this is how the matrices are given. Then the question is what? Then the question is, how can I put the parentheses? I could have put it like this, or I can do it like this, right? A1, A2 first, then A3, A4. This is one way. So this will give one solution. So suppose A1, A2, suppose this is another solution. Okay, so this is another solution. This is going to another solution. Then A1, A2, A3, A4. I'll put it something like this. So A1, A2, first this and this. Sorry. So this is another solution. Then there are different solutions possible, right? So then which one is going to be giving the better one? So then we will apply the matrix and multiplication. Okay. Then in this particular situation, we are going to use the similar case that we are going to use in the LCS. We are going to use some matrix. Okay, some matrix. Okay, let's do it like this. So just to do a table here. Just do a table here. Table here. Okay. So I am just going to put how many number of rows, number of column 1 2 3 4. Number of matrices, how many number of matrices? 4 number of matrices, right? So I am going to take 4 plus 4 matrices. Okay, 1 2 3 4. Okay, so 4 matrices. Okay, so then obviously if this is going to be 1 1, just see. So can I put 0 0 0 0 here? Can I put 0 0 0 0 here? Why? Because if I am going to multiply 1 to 1, that means same matrix, right? Same matrix. 1 to 1 means same matrix, means A1 1. So then there is no more multiplication is needed. Similarly 2 2 0 3 3 0 3 4 4 0, right? So if it is similar same matrix, so then I am going to put the diagonally. Okay, now I am going to find out what is the number of operation if I am going to multiply A1 matrix with A2. Okay, if I am going to multiply step 1, just write step 1. Okay, step 1. So I am going to multiply A1 A2. Okay, so A1 with A2. So if I am going to multiply A1 with A2, means what I am trying to say, what I am trying to 1 to 2 means okay, so if I am going to find out what is 1 to 2, just try to find out what is the value of A1 2. Okay, in step 1, what I will try to do, first of all try to A1 to A3 4. So I will try like this. Okay, 1 to first, 3 4 5. Okay, so let's we will go for 3 4 and all. Okay, so just find out what is the number of operations so needed for A12. Okay, A12. So what is the number of operations? Just find out. Okay. Is it done? What is the number of operations if I go for A12? What is the number of operations? 120. Okay. 120. Okay, good. So I think some of you have calculated. So okay, so this is going to be 120. Okay, so what is my objective? So you remember the objective, right? So my objective is what I'm going to calculate where A14 means if I'm going to take the whole matrix, okay, 121. If I'm going to take whole matrix, where should I put the parenthesis? So I'm just trying to find out the all possible combinations. Okay, that's good. 120. Yeah, answer is 120. So then my question is, so then I am going to find out 1 4. That means 1 4 till first to last. What is the number of operation I needed? So what I will use? I will use the sub problem solutions. Okay, so I will calculate A1 A2. Okay, so then A2 A3. Okay, A2 A3, then A3 A4. So this is the first solution, or this is the first step. So because I am trying to find out who are the mutual to each other, so I am going to find out these two with these three values. Okay, so this whenever we are multiplying, so I just tell one formula, right? So I will build up that formula simultaneously. M of A13. Sorry. So A12 means M of 12. Okay, which is 120. Okay, and I will write. So just calculate for others. Okay, so like M of A23 means M of 23. This is matrix M. Okay, I have another S matrix actually, which is M of 23 equal to 48. We will get 48. Okay, I'm just writing it down. I have noted it down already. 3 4 equal to 84. Okay, so you are going to get it. 1 2 is 120 and 2 3 is 48 and this is 84. So just fill up this particular table. Okay, and fill up this particular table, and there is another table. Okay, there is another table, S table. So which is going to tell where exactly. Here we are just keeping the numbers, right? Here we are just keeping the numbers, but our objective is to put that thing, which one, the bracket, right? So then the question is, then in this particular thing, which is the minimum one out of these three? Which is the minimum one? Which is the minimum one? 48, right? 48 means this is the, what is the A23? A23, this is the minimum one. Okay, so we will update accordingly the S matrix. So this was the step 1 matrix, 48, right? Correct. So this was the step 1 where I am just calculating the pair of matrix. That means A11, sorry, A12, A23, A32, A34. So this is the thing. Okay, then in the step 2, what you will do, you will put the parenthesis. We'll see how to do that. Then write it down. Step 2. Okay, step 2, you are going to calculate M of 1 3, M of 2 4. I am taking two matrix. Now I have got, so how we are going to solve this particular thing? We are going to use these values. This is the known as sub problem, means how we are using the optimal solution, small optimal solutions, sub problem solutions to get the main problem solution. So whenever I am going for calculating M of 1 3, I will be using some of the thing. Okay. The question is, how can I evaluate M of 1 3? M of 1 3 means 1 2 3, means how can you order these things? Okay, so that is the question. So M of 1 3, then question is, how can we write like this? Okay, what will be the solution? So just tell me, if I am going to order this one, A1 A2 A3, M of 1 3 means what? I am just trying to order A1 A2 A3. Okay, A1 A2 A3, then what is the possible solution? I can go for here, there are two solutions, right? There are two possible situations. I can go like this, A1 A2 first, then A3. Okay, or else A1 A2 A3. This is the situation. Do you understand these two situations? And if you will realize, we have already calculated A1 A2, we have already calculated A2 A3. If you realize, in the previous step, in the step, if you see this step number 1, we have already calculated A1 A2. A1 A2 means M of 1 2, right? A2 A3 means M of 2 3. Do you realize? First of all, let's understand first. So I am trying to find out the solution for M of 1 3. Then what I need to find out? Then if you see, what will be the possible solution? A1 A2 will be multiplied first, then we are going to multiply A3, or else I am going to multiply A1 with A2 A3 first. Means this is the solutions. Do you understand this? Just type yes if you understand these things. Because if you understand these things, then we are done. Because we know the value of this, we know the value of this already, and we just calculate this one into multiplied by this one. So then we are done. I think then we are done. We don't have need to do anything. But do you understand this? Okay. Selection message okay. So this is okay. 88. You understand this? So if I will write in case of recursively, just write yes or no. I will explain otherwise. But yeah, I'll just tell you. So if I'll write it recursively, which is nothing but minimum of. So if you think about this one, okay. So this one, okay. So this one is nothing but M11, right? M11. So this is M23, right? M23, M23. So this is M11, M23, right? So this is what? M12, M33. Do you understand this notation? Because this is A3. A3 means A1. Suppose this is, think about A1. A1 means M11. M11 means this one. A1 means if I take only a single matrix, I don't need any operations. So then it is 0. So no need to. So I'm just trying to mapping this one into M terms. If a single matrix, then 1 1. If there are two matrix, then M2 3. Okay, Dharas says yes. Okay. Okay. So M12. Okay, M12 means M12. M33. Okay, then the question is, if I'll just write in this way. Okay, so the formula that I used, okay, so it is nothing but M11. What is the minimum of M11 into plus M23? So we will get some value from here plus the number of operations here into what is the number. So what is the value of this one actually? M11, M23, and the number of operation needed to multiply this one. That means plus some PQR or PQR something or MNP. Do you understand this? How I will multiply these two matrices? The number of operation needed for this particular matrix is stored in M11. The number of operation needed for this is already being calculated in the step 1 and which is stored in M23. But whenever I will multiply these two matrices also, I'll get some numbers, right? I need some operation because it is having some dimension PQ, it is having QR, then PQR, then the number of operation needed is PQR, right? So in that particular situation, okay, so then I will have some additional PQR or MNP, whatever may be. Okay, so then I'm writing minimum of the same thing I'm writing. Just try to see and let me know. Minimum of, if I'm calculating M of 1 3, okay, minimum of M of 1 comma 1 comma, okay, sorry, M of 1 comma 1, this one I am typing, first one, this one, plus M of 2 comma 3, okay, so this is very important, 2 comma 3 plus some, I don't know, P of I minus 1, P of K, P of J, some number. So this is the number of operation needed to evaluate A1, okay, which is stored in, this is M matrix, M11 which is 0. So the number of operation needed for 2 4, 2 3, which is stored here. We don't need to calculate because we have already calculated in step 2. Okay, so then Pi minus 1 K Pk Pj. Okay, so that we need to calculate. This one we need to calculate. So this term, so just write it down. Just tell me what is the value of this, what is the value of this, and what is the value of this. Just tell me the final value. Okay, x equal to this plus this plus this. There will be summation of 3 terms because this is 3 terms, right? So x equal to, I think it is not visible. X equal to summation of 3 terms. Just tell me the value of this particular term, which is M11 plus M23 plus Pi minus 1 Pk Pj. Just tell me the value of this one. What is the value of this x? Just tell me the value. Just tell me the value of this particular thing. Like this way, right? Just tell me. Just tell me the value of this. I'll write something here. Yes, Susmita says 106. Okay, yeah, I need the 3 term individually also. This plus this plus this. Okay, 3 terms. There's 3 terms, right? So what is the value of this? What is the value of this? What is the value of this? 3 terms, which is equal to x. Okay. Okay, zeros plus 48 plus 60. Okay, I don't know. Let's see. Okay, so what about others? What about others? Or you are not following? Are you able to understand or no? you guys able to understand, or you want to make a repeat? So this is the step. Maybe you want me to make a repeat of this particular how to calculate M13. Sorry, it's 88 maybe. What is P? Yeah, that's a question. What is P? I also don't know. You are just multiplying two matrices. So if it is a size MNP, so you can write MNP. That's okay. MNP. MNP. Okay, let me write it. Okay, so everybody just think it in your way. But yeah, I'll just write it clearly so that you will able to understand what is going on actually. Yeah, just try it by yourself. Okay. I'll explain what do you mean by everything. Okay. Okay, so 0 plus 48 was question mark. Okay, so whoever understood or not, just give a pause. Okay, so we'll understand this one in a proper manner. Okay, so means, because yeah, it is little bit complicated, I know, but just try to understand. So whenever a matrix, so I'm just deviating from the topic. Whenever a matrix A1 and A2 are given, the number of operations, suppose this is 2 cross 3, this is 3 cross 4. The number of operation is 2 cross 3 cross 4. Okay, so how you are calculating? So you are taking the first term and the second term, this one or this one, both are same, and this one. Okay, so whenever you are doing a multiplication 1 into 2, okay, so what you are doing, so if I'll give a number, so this is going to be 0 1 2 3. So I'm just giving a number. Okay, 0 1 2 3. Okay, so suppose there are two matrix, or you can give actually these two as, no, not, just combine this one, 0 1 2. Okay, number like this. So there are two matrix 1 2. So this is going to be same. So the what is the output you are going to get? 0 1. 1 means 3 and 2. Okay, so 0 1 2. So that's why whenever you are multiplying two matrix, I can write it, if it is 1 2 matrix, so this is 0, that means P of I minus 1. Okay, so if it is 1, then it is going to be I minus 1. So if it is 1, this is going to be 1. So then Pj, okay, this is Pk. Okay, if I is having dimension I cross j, okay, whatever maybe. 1 means 0. Okay, if I'm getting a numbering, so that's I just make a simple notation. P of I minus 1. If it is a A1 matrix, then I will go for the 0th index, then first index, then second index, then P of I minus 1, then jth index Pj, okay, and then Pk. Okay, so this is the small notation, or I can write also m cross n cross p. If the size is m cross n, this is m cross n or n cross p, so then I can write m cross n cross p. Generally, whatever it we have written just in terms of I and jth notation. Why? Because I am going to apply some for loop, right? In that case, I and j is going to be your iteration. So that's why P of I minus 1 j pk. Okay, so we'll understand this. So this one is just a small point to understand what is pi minus 1 pj pk. It is nothing but 2 cross 3 cross 4. You can say like this, 2 cross 3 cross 4. If you are multiplying 2 cross 3 matrix with 3 cross 4, so it is nothing but 2 cross 3 cross 4. Okay, so this was first part. Okay, then coming to the second part. Whenever you are going to calculate 1 cross 3, m of 1 3, m of 1 3 means we are giving 4 matrix, right? 1 a1 a2 a3 a4, a1 a2 a3 a4. What does that mean? How can you construct? Okay, by taking, by taking 3 at a time, 1 to 3 at a time. Okay, so if I think about a1 3, so this particular matrix, if I think, then I can construct in these two ways. Either I can multiply a1 a2 first, then a3, okay, or else I can first calculate A2 A3, then I can multiply A1. Okay, so that is all about these two situations. So then I need to find out whoever is minimum among these things, among these two possible solutions, then I am going to take that one. Okay, so that term I have represented in a recursive formula for. Okay, so this is how we have represented. So if you think about this way, this one, what was this actually? A12 means m of 1 2. AJ means A3 means A33. Sorry, M33. So that is the same thing I have written. Just to make it this one actually. M12. M12 means first of all multiply A1 A2, multiply A1 A2, then 3, then with 3. Okay, and then if you will multiply these two, this is going to give some solution. This is going to give some solution. Means it is giving suppose 2 cross 3. This is giving 3 cross 4. Then in order to find the solution of whole, you need to multiply these three, right? 2 cross 3 cross 4. So this is nothing but the pi minus 1, pj, pk. Okay, so this is nothing but this one. Okay, and similarly you can get this one. This one is this solution. A1 is multiplied with A2 A3. A23 means 2 3 A23. Then after getting the solution, you are again going to multiply these two, which is A1 A2 A3. That means P of I minus j, I minus 1, pj and pk. Okay, so let's first calculate actually. So if you will calculate, you will get able to understand. Okay, so how exactly this is going to be find out. So let's first calculate which one. This one, whatever may be. So just tell me what is the value of M11. M11 is 0. Then M11 is 0. How you are getting? 1 2 3 4. M11 is 0. 1 1 is 0. Okay, 1 1 is 0. 1 1 is 0. Because I same matrix, right? I am not multiplying with anyone. So how about M23? What is the value of M23? M23 we already got it from here. 2 3 we have already calculated. That is 48. Okay. The value of this particular M23, just one second. So this is 2 3 is 48. Okay, 48. Okay, so then what is the value of this one? This one is nothing but, so what are the things you are multiplying? M11 means A matrix, right, or A1 matrix. Then M23 means A2 A comma 3. So tell me what was, oh, that is not there. So if I multiply A23, what is the dimension of A23? I don't know. Let me see my copy actually. 2 3 2 was 4 cross 6, and 3 was 6 cross 2. 6 cross 2. So this matrix dimension was 4 cross 6 cross 2. Okay. So the dimension of this one was 4 cross 6 cross 2. So A1 matrix course was, so the number of operation, the dimension is not like that. Dimension is 4 cross 2. The A1 was 5 cross 4. 5 cross 4. Now what is the value of this one? Pi minus 1. Then tell me what is, if it is a 5 cross 4, if it is a 4 cross 2, then this is going to be 5 cross 4 cross 2. You got it? I think some folks have already written 48 plus 40. Yeah, but that's okay. But do you got it? Okay, so this is the solution. Okay, so then it is going to be how much? 48 plus 48 plus 40, which is 88. Okay, 88. So this was for this solution, but we need to find both approach, right? There is another way. There is also another way. Just tell me what is the answer for this one. M12, do you know what is the value of M12? Yes, 120. Okay, then how about M33? M33 is 0. Okay, then how about this one? Who can tell this one? This one is nothing but, tell me what is the dimension of M12? M12 means this is 1 2. That means A12, A1 A2. So after multiplying A1 A2, so it should be 4 cross 5 cross 6 matrix. So this is going to be 5 cross 6 matrix. And how about M33? M33 is nothing but 6 cross 2 matrix. 6 cross 2 matrix. So if this is the case, then the solution is going to be 5 cross 6 cross 2. Okay, so this is going to be 5 plus 6 equals to whatever may be, so 120 plus this is 32, which is equal to 152. Okay, so do you got this one or anything else? Do you guys got it? So then we need to find out which is the minimum. 88 is the minimum, so we are going to consider the solution of this one. Okay, so this is 1 1, okay, plus 2 3. Okay, so this is the going to be the solution. What was this one? This was, it was like this, right? A1 first, A2 3 is going to be multiplied. Okay, so do you got it? A2 3 is going to be multiplied. So this is the solution whenever we are taking 1 3. Okay, somebody says 60. Okay, yeah, this is 60, right? Sorry. Yeah, this is not 32. I just added actually 60. Then it is going to be 180, right? Yeah, that's true. Yeah, Dharasri says, sir, value of k is less than or j or not? Yeah, it is. Just 1 second, guys. I'm getting a call. I'll just back in a minute. But just try for this one. Okay, M13 we have tried, right? But 1 3 means A1, A2, A3, right? So A4. But we had another choice. So these three we had taken. But I could have taken 1, 2, 3, 4, right? So this was one solution, M13. Try to calculate M24. 24. Try to calculate M24. Okay, I will be just back in a minute. Just try to calculate, write down what will be the solution, what will be the different values, and what is the value of 24. I'll just back in a minute. Okay. Hey, hi guys. Sorry, I got a call, urgent call. So, where are we? So, do we get the answer? Okay, I think it can't be 32. Mm, yeah, it can't be 32. Yeah, that was my wrong actually, mistake. So it should be 5 plus 6 plus 2. So which is 60. Yeah, that's true. Yeah. So yeah, for this particular situation, so what I'll do it, finish it quickly because I think we are running out of time. 5 o'clock. Okay. So let's complete it in 5 minutes. Okay. So for 2 3, I think we are going to calculate it in 2 4. We are going to calculate the similar fashion. Okay. So I'll just write it down for 2 4. Just 1 second. Okay, just do this one. Okay, in your home, in your home. Okay, 2 4 for m of 2 4. So it is going to be a2. This is one solution. Okay, and the another solution is this one. Okay, just write in matrix form. Matrix form means this is going to be m22. Okay, m22. You write it in your home, right? Okay, so this is going to be m34. Okay, and this is going to be m23, and this is going to be m44. Okay, and there will be some pqj, pi minus 1, pk, pj. Okay, and this similar way. Okay, so just find out this one similarly. So this is the m24. So after that, whichever is minimum, that is going to be updated. Okay, as 1 3, f of 1 1 3 and 1 4. So these things, sorry, 1 3 and 2 2 4. So this is going to be updated. Okay, so once you update this, so then you are going to find out m of 1 4, which is the solution, because our objective was to m1 a1 a2 a3 a4. Okay, so this was our objective. Okay, so this was our objective. So just find out this one. So this will having the same situation. Okay, so just try to find out this one. I will check everybody. Okay, so just I will check the solution. Okay, let me write. Okay, yeah. So the time complexity is order of NQ because I am checking for each and everything. But just 1 second. Just give me 1 second. Okay, so I'll write down the solution. You can just cross check once in your home maybe. Okay, let me see what was the solution. Just 1 minute. Just 1 minute, guys. I think we will just end now. Okay, so you can just find out the similar way. Okay, how we have calculated, and just let me know if you are getting any doubt or something like that. Just 1 second. I'll just write down the solution. Yeah, 120, 88. So this will be 88. Okay, I think this we have already calculated. Okay, so this is going to be 158. Okay, and this is going to be 104. 104. This is going to be 104, and this is going to be 88. So this is the solution. Okay, so this is the solution. This part is going to be blank. Okay, but this is the solution. Okay, so you can find out in this manner. So that's all about it. Just try to find out this. I think we have calculated m24. Just find out m14 in the similar fashion. Okay, and just try to fill this one. Okay, so this is the solution. So this is the 158. So this is the 14. That means m14 means this one. Okay, so this is the solution about this one. Okay. Just I will just write it this one actually, so that you can calculate easily. It visible or not, I'm not sure. P of I minus 1. Yeah, just write this one. Okay, so this is how you are going to get the solution. P of 1 4, how you will get? So yeah, but that's okay. So just quickly, so m of 1 1 plus m of 2 2, sorry 2 4, pi minus 1 pj pk, f 1 2 3 4 I minus 1, this is like the same thing, pi minus 1 pj pk, and p m of 1 3 1 3 m of 1 4 pi minus 1 pj pk. Okay, so like Dharasri you are asking, right, it will go for less than only, it is strictly less than. So 1 1 1 2 1 3. Okay, just try to calculate this way. Okay, so this is the thing about the matrix and multiplication. It is having order of NQ. Okay, so that was all about this matrix and multiplication. So maybe I think we are running out of time, so we can leave for the day. But yeah, just try this, and just if this is the solution, if you are not finding anything, just let me know. Okay, okay guys, thank you.